Hello everyone, welcome to this session, Building Web Applications with Advanced Routing Capabilities. My name is Max Zheng. I'm a product engineer on Network Analyst team, focusing on routing services. And with me here today is Noah Sager, and he is a product engineer on the ArcGIS API for JavaScript team, and he specializes in printing, labeling, and all things routing. In this session, we will provide an overview of the routing capabilities available with ArcGIS Platform and how you can use it in your web applications using ArcGIS API for JavaScript. So before we start, here is a URL that includes all the contents we'll be covering in the presentation today, including the slides and code samples. You can download it from this URL, and we'll make it easier for you to follow along this presentation and understand the code samples. Here are the content we'll be covering today. We will start with an introduction to routing services available with ArcGIS Platform, and I will show you the simplest routing service, which is to find a route between 2 points. And then Noah will show you a demo using the directions widget with the ArcGIS API for JavaScript. Then we will continue our journey to learn all the other routing services, and I will show you what they can do and highlight some of the capabilities for each of the service. And next, I will show you a demo that routes a fleet of vehicles to deliver goods using fleet routing services. And Noah will take this workflow and show you how to do fleet routing with ArcGIS API for JavaScript. So let's get started with routing services. For this presentation, I will use this developer site to show you the routing services. Since this is a new developer experience, so I want to show you how you can navigate through this system to find the things you need and help you get started with learning and using our services. For the first part of the presentation, I will mostly explain where to find the documentation for various things and explain in detail how the documentation is structured. Here we are at the developers.arcgis.com, the main landing page. To access the documentation for routing services, we first go to documentation. The ArcGIS developer site has been redesigned to give you easy access to mapping and location services capabilities, and routing service is a key part of location services. So we can click this Learn More to go to the Mapping and Location Services talk. And here, it describes ArcGIS Platform, which is a new Esri offering for developers to gain access to REST services offered by Esri through various Esri APIs, open source APIs. This ArcGIS platform is also using standard API key to control how to access services, and the credit usage will be based on consumption of the services. So once you follow the steps to get an account and set up an API key with correct services enabled, you will be able to use it to access services very easily, and Noah will show you how to use API keys to access routing services in his demo. Just to make sure you know about this, the standard way of accessing routing services through ArcGIS API account token and app ID and app secret is still available. This API key is just a new way to access Esri services. And since it is new, we want to show you how to use it. And if you are interested in learning ArcGIS Platform or API key, there are dedicated sessions in Depth Summit to cover this topic. And there is also an ArcGIS Platform launch event, which you can look at on YouTube. Okay, let's move on to talk about routing services. So from here, we can go to routing. The route and directions topic gave you an overview of the routing services. When we talk about routing service, you are probably thinking about the most common workflow to find a route between point A and point B. Esri routing service isn't one service. It is a set of 6 services Esri provides to solve different types of problems. We have point-to-point routing service that helps you to find routes and generate directions, the most common workflow. We also have services that could help to route a fleet of vehicles, or to find the closest facilities, or to identify a drive time area around the location, or to generate OD cost metrics, or do site selection. We will look at each of the routing service and the capabilities in detail throughout this presentation. But first, let's go to the service topic that talks about the common things between all routing services. So for any kind of routing service, it's routed on top of real-world street data and also use traffic to help figure out the best route. So some of the key features shared across Esri routing services include we have high-quality streets data with global coverage. And the quantity could vary between regions, and we have a map service to show you what coverage we have for each area. You can click the service data to access this map service. The darker the green means a better streets and traffic quantity we have for that region. And if you are interested in a particular country, you can click this link to get to a table that lists all the streets data coverage per country. So back to other features shared between our 6 services. We find routes based on predictive, live, or historical traffic depends on when your analysis starts. All the routing services takes a travel mode parameter to help you find the best route for your type of travel. I will show you a quick demo about travel mode and let you know why it matters. So what we are looking at here is called 11-foot 8 bridge. It is a low clearance bridge in Durham, North Carolina. The bridge gets its name because it only allows vehicles under 11 feet and 8 inches to pass through. Since 2008, there are more than 100 crashes happened in this intersection because of the unusually low clearance. And let's see how travel mode could help to avoid this situation. Here, we first solve a route using a driving time travel mode, which models a regular vehicle. It tells us to go under the bridge, which makes sense. And then let's see we are driving a 4-meter tow truck, which cannot pass through this bridge. What we can do is we can go to our organization to create a tow truck travel mode. This is something an administrator of the organization can configure on the organization. So here I'm signed into an admin account, go to my organization, go to settings, and go to the utility services. And we can scroll down to the directions and routing section. Here you can create new travel mode, or duplicate or edit existing travel mode. Here we create a special travel mode called 4-meter truck that is based on the tracking time travel mode. And let's take a look at its travel mode. So one of the special things I want to highlight here is we are setting the height restriction of the vehicle to be 4 meters to match the vehicle that we are driving. And once you have this travel mode configured, then you will be able to use it in the directions widget. Here, when we switch to this 4-meter truck, it's going to take us a detour to help avoid crashing under the bridge. So this is how travel mode is used. Travel mode essentially models how a vehicle or a pedestrian can travel on the streets. For example, if your vehicle is tall or wide or long or it carries hazmat, then certain areas might not be accessible to your vehicle. Also, some vehicles are not able to make U-turns like school bus. All of these constraints for your type of travel can be modeled using travel mode. We provide some standard travel mode for driving, walking, and for trucks. But you can also create travel mode on the fly based on your mode of travel and pass to the routing services, and we will obey it in the analysis. The travel mode also allows you to set additional restrictions such as avoid toll roads or use preferred truck routes. In some scenarios, the actual routing street is available to travel for your travel mode, but it could be temporarily restricted or temporarily slowed down due to events or severe weather conditions like flood or rainstorm. All the routing services support dynamic barriers to help model these situations. The point or line or polygon type of barriers could help to either restrict travel or slow down travel for a particular area or location. For several routing services that support generic directions, Esri routing services support to generate directions in many languages. Now let's drill down to the details about our first routing service, point-to-point routing. And for the first one, I will explain in detail how the documentation is structured. And when we look at the other services, I will only focus on what they do and highlight some of the capabilities. We can first see a demo app on this page that uses JavaScript API to call the routing services. Here, when we click 2 points on the map, it finds a route and prints out the turn-by-turn directions. If you are interested in the code, you can click the CodePen link to open it in the CodePen. So besides finding a route between 2 points as the demo shows, it could also find routes between a set of points. It can find routes using sequence you specify, or it could also reorder them to find the optimal route that travels through a set of stops, which is called optimized route. So one important thing I want to make sure you understand is that for most Esri routing services, there are 2 ways to access it: direct request and job request. Direct request, which sometimes we call it synchronized service, is used to handle smaller problems which normally solves quickly. Job request, which sometimes we call it asynchronous service, is used to handle larger problems which normally takes a long time to solve. And the benefit of using direct request is it is faster to solve smaller problems. To figure out whether your problem should use direct request or job request, you can look at the request limits and decide. For example, for the route service, direct request supports up to 150 stops, and job request support up to 10,000 stops. And direct request has a usage timeout of 5 minutes, while job request has a usage timeout of 60 minutes. There are other limits to consider as well, and you can rate and decide based on the type of application you are trying to create. Once you know the problem you are trying to solve, whether you should be using direct request or job request, then you can just look at the doc for the request type of your choice. You can use this switcher to switch between direct request and job request. As we can see, the REST endpoint is different between direct request and job request. And the way to pass parameters is also different. For example, direct request takes camel case, while job request parameters are snake case. And there are other differences as well. So it is very important for you to first figure out whether your application is gonna use direct or job and refer to the correct documentation. Although the endpoint and the way to pass parameter is different, the parameters that are supported by direct request and job request is comparable. You should be able to model your problem using either direct or job, so the choice is mostly based on the service limits. Let's take direct request as an example and see what are some of the key parameters you can pass to the point-to-point routing service. The stops define locations your router is gonna visit. Travel mode is a mode of transportation as I explained previously. You will be able to use travel mode pre-configured on your organization or create your own travel mode to model your type of vehicle. Start time allows you to specify when the route begins. You can pass now if you want the route to start now, and it will use live traffic when finding the route. Set find best sequence to true if you want the service to reorder the sequence to visit all the stops. This gives you the optimal order to visit a set of stops, which is also known as traveling salesman problem. Setting find best sequence will change your problem from simple routing to optimized routing, so additional service credits will incur. Set return directions to true and set the directions language of your choice if you want to get turn-by-turn directions. So these are just some of the most common parameters you can set on the routing services. There are a lot more parameters you can set to fine-tune your route analysis. And if you want to learn more about them, we can go to the REST API doc, and it explains all the parameters you can pass to the routing service in detail. So in this new developer site, we are also giving an example for a direct request and a job request. It first gives a problem statement of what we are trying to solve and why we pick direct versus job, and then show you how to access routing services using various APIs. You can pick the API of your choice, and it will show you the example of that API. For example, if you are a Python developer, you might want to look at the Python API examples. And if you are a JavaScript developer, you might want to switch to JavaScript API examples. And if you are comfortable working directly with REST API, we also show examples of how to access the services using either curl or HTTP. And if you want to take a look at the sample response, you can switch to the response tab. So the way to access job requests through pure REST is slightly different than direct request. Job request first submits a job to the server and get a job ID back from the server. Then you can use the job ID to query the job status. And once the job is finished, you can use the job ID to access the output. And all of this is explained in the doc as well. So for this first service that we talk about today, I gave you an overview of how the documentation is structured, how to decide between direct request and job request, what are the capabilities supported by all the services, and where to find samples to access direct request or job request based on the API of your choice. Hopefully this gives you an overview of how the documentation is structured so you can get to what you need quickly. Now I will hand it off to Noah for a demo using the directions widget with the ArcGIS API for JavaScript.
Hey, thank you, Max. All right, let's look at a real live demo using the Directions widget with the ArcGIS API for JavaScript. On the screen, you can see a screenshot of the application with the route going from Esri's main campus to the Palm Springs Convention Center. This is the usual route we would take to work during Dev Summit. However, since we can't be together this time, I thought it'd be fun to do something a little bit different. At the bottom of the screen, you can see a link to the application hosted on GitHub that is accessible to you now. The app will also be packaged up with the other resources that'll be available to you after this presentation. So let's go ahead and exit out of the presentation and let's look at the app. Here we can see the location of NFL teams in a portion of the United States. The location of each stadium is marked with the football symbol, and the name of the team is displayed in a label above. In the top right of the application, we can see the Directions widget with 2 search boxes and a couple drop-downs for options. So let's go over our scenario. I would like to help out my friend Tom Brady, who recently won the Super Bowl, make his way from the stadium to Disney World so he can celebrate his victory with his friends and family. However, I don't remember where the stadium is or even what the name of the stadium is. Fortunately, I have some help. So let's go over to the first search box and I'm going to look up Tampa Bay Buck for the Tampa Bay Buccaneers. And there we are, Tampa Bay Buccaneers. And oh yeah, they play at Raymond James Stadium. So I'll select that as my start point. Next, I want to help Tom Brady get to Disney World because Disneyland is in California, but Disney World is the place in Florida where they like to go and celebrate. So now I have my start point at the Raymond James Stadium and my end point at Disney World. And it looks like it'll take about an hour and 13 minutes to get there. Now, let's look at some of the other options the Direction widget offers by default. The first is the travel mode. By default, we're using drive time, but we could also be using driving distance or trucking time or even walking time. However, in this situation, it's probably most appropriate to use driving time. Second, let's look at our start time. We have a couple options. One is leave now, which means leave now. We could also use the depart by, which if we select this option, we get a handy date and time picker. So if I want to travel back in time and go back to Super Bowl Sunday, and obviously he's not going to leave before the game starts, but he might leave after the game and all the celebration ends. So let's say about 11:30 p.m. So there, now we see that the route has been updated and will only take an hour and 9 minutes to get to their destination. Now, the way the time is calculated is by using the World Traffic Service to gauge how long it would take to get from point A to point B. So it's not using live traffic, but it's using an amalgamation of historical traffic data. The last option we had for our start time was time unspecified. So if I select that, we can see that the route changes a bit again, and it'll take an hour and 15 minutes to get there. The reason the time has changed is because when you select time unspecified, it takes the average across all different times of day and gives you that back as the duration from start to finish. Another nice feature of the Directions widget is that if you scroll down, you can actually see that each individual route segment is selectable and actually displays in the route segment on the map. And if I click one, it will actually zoom into that segment of the route, and so I can see clearly where the beginning and end of each route segment is. This can be especially helpful if you like to plan ahead like I do for your directions so you know which lane to be in for which exit. And of course, after you're done with your routing, or if you'd like to start a new route, you can easily click the Clear Route button right in the middle of the Directions widget. Clicking this will remove all the features and you'll be left with a clean Directions widget, which still has the same settings that you specified the last time that you used it. All right, now that I've showed you what it does, let's take a look at how it works. So by opening up the developer tools in my browser of choice, I can go ahead and see the source code for this sample application. A couple of things I want to draw your attention to. The first is the version of the API we're using is Next. And this is available here at this URL. Next is actually the latest cutting edge version of the API. We do not recommend it for production applications as the API changes on a regular basis. But if you want the latest features and you want to see what the updates are, you can go ahead, go to this URL in GitHub, and you can start using the latest version for development today. All right, so in our require statement, we've got a couple modules. Of course, the most important is our directions widget. We're also going to be bringing in Esri config for our API keys, which we'll talk about in a moment. And then we're going to bring in a locator task and a couple other modules to support the actual aesthetics of the map. So let's look at the API key first. The API key is a property of Esri config, and here I've put in my API key from my developer's account, and of course I have it enabled for routing and for geocoding. Then we have the label class for our feature layer, and then we have the feature layer itself coming from an instance of Portal, and we have our base map. We're actually using a really nice version of the Firefly base map, but we've removed the references to make the appearance a bit cleaner. And then of course we add the layer to the layers property inside the map constructor. Then we set the view to a reasonable place on the planet, and then we create the directions widget. So the directions widget has a few properties that we have to have. Some of them include the view. We want to associate the correct view of the map to the directions widget. And then we have some nice optional parameters that are really helpful for this application. The first one is called search properties. And what we're going to do is we don't want to use the default sources because we're going to use some magic here to make it a bit more special. Inside the search properties, we have a sources property, which takes several parameters. So the first thing we're going to do is we're going to have a layer locator. So we've got that handy football layer of all the football stadiums, and we actually want to search on that because sometimes I worry that the geocoding service might not get the correct stadium or might not actually have all the updated stadiums in their database. So I prefer to use this layer as the actual source. So the layer is the football layer, which we defined above. The search fields, you can search on the name, which would be the actual stadium name, the team, which is the name of the team, and the city that they play in. Now we saw before when I entered in Tampa Bay Bucks, I got back the name of the team, Tampa Bay Buccaneers, as well as the name of the stadium. And I actually formatted that in the suggestion template to help users understand the choice that they're making is either the correct one or the incorrect one. Then we don't need to have an exact match. We can do a partial match, and we want to allow all the different outfields possible. Now we could restrict the outfields to just being those in the suggestion template, but I figure why restrict things? Let's allow everything. Lastly, or not lastly, but next we'll want to include a helpful placeholder. So if you're not sure what you're looking for, we highly recommend using the New England Patriots to test out your data. We give the locator a helpful name to differentiate it from other locators which might exist in our application. So football locator seems pretty obvious. And then we assign a reasonable zoom scale so that when a search is found, that will be the scale of the view once it's located. Also, the ordering here in the sources is important. I want the football locator to come up first before our other default locator so that if I'm searching for football stadiums, it'll be easy to find those suggestions above the locator. So here we're going to use another locator. This is going to be a standard search source locator. I'm assigning the URL that's appropriate for working with API keys, which is the geocode-API. And then of course I have a helpful placeholder and I give it a name which is the default locator. Lastly, and arguably the most important for the directions widget, I want to make sure I'm using the appropriate route service URL. This is the actual URL that will be called when the widget does routing. And here I'm using the one appropriate for API keys, which is the route-API. And then the last little bit of code is just adding the directions widget to the top right. Now the directions widget is extremely powerful and extremely simple, and you can see with just a little customization, I can make it do something a little unusual, which is really fun. However, it's worth going through the documentation to show you just how you can find all this information and what properties are available to you. So let's look at the doc. The first thing I want to show you is the Esri config module. This is where we set the API key. If I go down to properties, I can see that the first property is API key. And this is our authorization string to access resources. And this helps me access premium resources at Esri, as well as actually track the usage so I can see how my users are using these applications. And here is the doc for the directions widget. It starts off with a really nice description of what the directions widget is and how to work with it. But there's a couple things here that I want to draw your attention to. The first is, if we go under properties, we see that search properties that we looked at before in the application. Now, search properties is a property of the directions widget, but it's of type search properties, which is just a type def that we made to make it a bit easier to work with these sorts of properties that have lots of nested properties beneath them. So if I click on that, I come to the search properties type def, and here we can see all the properties that are available to us. Now, some of these we defined in the app and some of them we just left alone. But it's good to know that some of these exist, such as location type. This can be really useful when working with the search widget, but it can also be helpful when you're working with the directions widget. Here you can define if you want to use the street location or the rooftop location of an address. So the street location would be the point closest to the address on the street, but the rooftop would actually be literally over the top of the address so that if the building or the location is far away from the street, you can still see exactly where it is. What we were interested in were the sources property. Now, sources can take a collection of two different types, or one of more types, a layer search source and a locator search source, and we use both of these in the sample application. But before we drill into those, I do want to draw your attention to the fact that when we talk about widgets in the ArcGIS API for JavaScript, we'll also need to talk about view models of those widgets. So in general, widgets handle the styling and the user experience, and the widget's view model actually handle the business logic. So let's look at the directions view model. This is very similar to the directions widget, except it has a couple more properties available to us. Now, some of the things like the travel mode we talked about earlier, that's a property that's available on the widget's view model. So if I come down here, I can see all the nested properties that make up the selected travel mode. And of course, we have the ability to define if we want to use miles or kilometers, or if we want to use travel truck time instead of the default driving time. And by default, the value is either null or it's the driving time. Another nice thing to point out is the methods that are available to us on the view model. So if we want to clear a certain highlight or clear the results or manually call the get directions method, all of that is available to us right here on the view model. Now let's switch back to those different sources. So first we have the locator search source, and we use this for our default source that we set at the bottom in the application. And here we have the properties that are available to us inside that source. And of course, the main one that we used was the actual URL to the locator. The next thing to talk about is the layer search source. And this is very similar to locator, but some of the properties are a little bit different because it's specific to working with the layer. And this is how we were able to use that football layer as an actual source for our searching inside of the directions widget. So it's not terribly complicated, but sometimes a lot of things are nested inside the other. And it's really useful if you're looking at the doc to click through and follow all the different properties and figure out where you can get the properties that you actually want to customize, or maybe you just want to read in your application. The last thing I want to point out, or the second to last thing I want to point out, is that next repo I was talking about. Here it is on GitHub. Here you can read about it, and you can also log issues. Since this is not a stable API, this is just for testing the latest features. If you find a bug, you're welcome to report it here. And of course, I want to point out this really handy extent finder that I used in creating the application to get just the right extent visible. This works with 2D and 3D. And of course gives it back to you in Web Mercator or WGS84, whichever spatial reference you're using in your map. And if you're using a state plane, you might need to use a more customized tool. So with that, let's go ahead and hand things back over to Max. So take it away, Max.
Thank you, Noah. That's a great demo. Now let's explore other routing services and see what they can do and what capabilities they support. Again, let's look at the developer stock since it has some sample applications that could illustrate the service in action. We will come back to the fleet routing service last since it is the most complex one. Let's take a look at the closest routing first. So closest facility service is used to find one or more closest facility to your incident. For example, you could find the closest fire department or fire truck to a fire incident. There are some constraints you could set on the service. For example, only return results that are within 5 minutes of driving time, or return the closest 3 facilities instead of 1. The sample app here shows using closest facility service to find the 3 closest gas stations from where you click on the map. So let's take a look at some of the key parameters that this service support. Facilities and incidents are input locations. Facilities are where you want to locate closest from, and incidents are where your incident happens. We have talked about travel modes shared across the service. Default target facility count allows you to specify how many closed facilities to return. For example, in our sample app, we set it to 3. Default cutoff allows you to specify when to stop searching for the facility. For example, only search for facilities that are within 5 minutes of driving time. Travel direction helps to define when you search for closest facility. Are you measuring the travel or distance from incident to facility, or from facility to incident? For example, when you are looking at closest fire trucks to fire incident, you will want to find the trucks that are closest to drive to the fire incident. When you are looking at the closest gas station from your current location as shown in the example, you will want to find the gas station that are closest to drive to from your current location. Next, let's talk about the travel cost metric service, which is also called origin destination cost metrics, since it has lots of similarity with the closed facility service that we were just talking about. Both service starts from 2 sets of locations. In closed facility, it is facilities and incidents, and in travel cost metric service, it's origins and destinations. Both of them solve many-to-many problems, but origin destinations doesn't return route shape and doesn't generate directions, and it also doesn't support travel direction. If you don't care about all these things, then you can use travel cost metric service since it is faster and cheaper to use than closed facility service. This service is very useful when you have 2 sets of locations and you want to find the time and distance from all origins to all destinations. Or if you just have 1 set of locations, and you can use it as both origins and destinations, and it will find you the time and distance between each pair of the inputs. So here, this picture shows you we are using these 5 locations as both origins and destinations, and we get the time and distance between each pair. This service is also widely used in scenarios like estimated time of arrival or ETA calculation, where you know your vehicle's current location and know the destination location, and you just want to know when it will arrive at the destination and not care about the actual route. As I explained, the key parameters are very similar to closed facility service, but it doesn't support return route shape or directions or travel direction. Next, we have the service area service. Service area service is used to show coverage of a facility. For example, you could find an area that are within 15 minutes of drive time to your store. This is different than buffer results since buffer is done using Euclidean distance, and service area actually takes the road network and traffic and all sorts of road conditions into consideration when generating the area. For example, the sample app shows you 5, 10, 15 minutes drive time from where you click on the map or where you click in the dropdown. And if you were to change to the walking time, the area will be considerably smaller. Some of the key parameters supported by the service area service include facilities, and it is the locations around which the service area is generated. Default breaks is the travel time or travel distance you want to search to generate the service area. You could set multiple values with comma-separated list of doubles to generate several service areas of various range around each facility. For example, in our sample app, we are generating for 5, 10, 15 minutes. Travel direction is used to specify when you say you want 5 minutes of driving time. Do you mean 5 minutes to drive to your facility or 5 minutes to drive away from your facility? For example, when we want to find our fire station coverage area, you will want to set to drive away from facility to visualize the area covered by fire truck starting at fire stations. When we want to find the store coverage area, you will want to set to drive towards facility to visualize the area when customers drive to the store. Time of day is used to specify when does the travel start. Depending on when the travel starts, the area could vary a lot based on traffic. Location allocation service is used to help you do site selection. For example, where should you open the next store to attract the largest demand or get the maximum coverage, or if you want to get 80% of market share, or if you need to close one of the retail store, which one to close. The image here shows you the best location to open a new fast food restaurant that can serve additional customers. This is a service widely used in business analysts. Some of the key parameters include facilities. This is your inputs to specify all the facilities to choose from. Demand points, which is your inputs to specify the demand locations and weight for each of the demand. Problem type allows you to specify the objective of this analysis. And number of facilities to find helps you decide how many facilities to pick. This is one of the more advanced routing services we provide, and it can help to solve a lot of problems with site selection. So if you are interested, we have very good documentation on how to use it and how to model your problem using location allocation service. Lastly, we have fleet routing service. It is used to route a fleet of vehicles. If you do delivery or inspection, and you have 5 vehicles that need to visit 100 locations in a day, which stops should be assigned to which vehicle, and how to route each vehicle so that the total cost is minimized. This is how this service is used. For example, the demo here shows you how to route 2 trucks to make 6 deliveries, and to minimize the overall cost. This is also a more advanced routing service that is widely used by a lot of logistics companies. Some of the key parameters that are supported by this service include orders, which is a set of locations to visit. When you specify orders, you will be able to specify constraints like time window or pickup and delivery quantity. Depot is the start and return locations for the vehicles. Routes is used to model the characteristics and constraints for each vehicle. For example, the total time the vehicle is allowed to operate, or the weight of the goods it can carry, or the driver's availability based on day of week or specialty, for example, if they can speak different languages. Default date is used to specify when the route will start, and you can set popular directions you want to get turn-by-turn direction. The fleet routing service is also a very complex service that could solve lots of your challenges in the logistics field. So getting the problem set up right isn't necessarily an easy job. I will show you an example of a fairly straightforward delivery example and show you how you can use fleet routing service to solve this problem and give you some tools that could help you to set your analysis correctly. So in this demo, we are a logistics company trying to route 3 trucks to deliver to 9 stores. And we are trying to assign stores to trucks and route these trucks in a way that minimizes the overall cost, but also try to balance the workload between 3 truck drivers. The costs we are considering including driver salary and cost to operate the trucks. On a high level, some of the constraints we are facing including each store has a delivery time window, and each driver has a max shift work hours, and trucks cannot easily make U-turns, and they have capacity limit. To really illustrate all the constraints from our business model into the fleet routing service, here is how we can map each of the business constraints into our input parameters. All the service parameters are very well documented, so you will be able to figure out how to model your business constraints into our service parameter by reading our REST API doc, especially if your problem isn't very complex. But as you can see, as the requirements get more complicated, it will become harder to get things right. So we need a way to try things out and inspect the result easily to make sure things work as expected before we setting up our service in a way to route the fleet of vehicles. For users who have access to ArcGIS Pro, this ad hoc workflow can be easily achieved using ArcGIS Pro. And the slides include a link to a video showing you how to model a vehicle routing problem in Pro from beginning. Because we have limited time here, I will just highlight some part of the workflow. Here, I have ArcGIS Pro open with the vehicle routing problem analysis layer set up to solve my analysis. When I create this vehicle routing problem analysis layer in Pro, I'm able to set up my network data source to ArcGIS Online. And when I create a layer, it creates a layer that uses ArcGIS Online as my network data source. And solve this layer is internally sending a request to the routing service and getting the result back. So the layer I have here is actually using ArcGIS Online as a network data source. I have preloaded this vehicle routing problem analysis layer with orders, depots, and routes that is used to model our analysis, and we can take a look at some of the settings we set on them. For orders, each store can accept orders between 9 a.m. and 5 p.m. For some of the analysis where the store can accept orders both morning and afternoon, we have the flexibility to set up two time windows. We set max violation time to 0, indicating the time window cannot be violated. We set the delivery quantity field on orders to indicate the weight of the appliance to deliver at each store. If both weight and volume is a concern to you, you can set up multiple delivery quantity fields. Next, for the depots. It opens at 8 a.m. and closes at 5 p.m. and that's the time the truck could come and pick up the orders. The name of the depot is San Francisco. For route, we have 3 records, which means we have 3 trucks to route in this example. The start depot name and end depot name needs to match the depot name you specified in your depots layer. The start depot service time is set up to 60 minutes, indicating it takes an hour to load the truck. We know this is 60 minutes because we set our vehicle routing problem analysis time units field to be minutes. This is used for both inputs and outputs. We want our drivers to start working at 8 a.m. sharp, so we set the earliest and latest start time to be 8 a.m. The max weight each vehicle can carry is 15,000. For cost per unit time, we set it to 0.4, which is $24 per hour, and that's the salary of our drivers. And the cost per unit distance is 1.5, which indicates each mile of driving costs $1.5. This is the cost for gasoline, mileage, and maintenance. We set the max order count to be 3 to balance the workload between our drivers. The max shift hours for our driver is 6 hours, so we set it to 360 minutes. And the max time for the driver to drive a vehicle is 3 hours, while the max mileage to drive is 100 miles. And this is for safety concerns. For this analysis, we set our travel mode to trucking time to model driving a truck. Since trucks are not very easy to make U-turns, so for the U-turn setting, we set it to no U-turn. We can solve this vehicle routing problem analysis layer to get the route for the 3 trucks. And when it is solving, it's actually sending a request to the fleet routing job request endpoint. And that's the same endpoint your job will hit against. And when the result comes back, we will be able to look at the result and see whether it satisfies your requirement. Here, we get our 3 routes back and each of the vehicles service 3 orders. Once you have your analysis set up in a way that you are satisfied, then you can look at the request ArcGIS Pro makes to the REST API by using the job ID to query the parameters. In our solve message, we are printing out the job ID. So similar to how you access the result by using the job ID. And once you have the job ID, you can construct this URL and get the job ID and what query for each of the input. To make things easier for you to use, I created a script tool that can do this automatically for you. So this is our script tool. You just need to provide a solver type. In our case, it's vehicle routing problem. And then we just paste the job ID from our solve message into here. And while it is running, it's actually querying for each of the input parameter and get what is the JSON that gets passed from Pro to the service. The script tool we are looking at here is included in the content URL I shared at the beginning of the presentation. There is also a command line utility version which can be run outside of ArcGIS Pro. And when we look at our JSON response, here is how it looks like. So this is the orders that the Pro client is making to the service. This is the JSON of the orders, JSON of the depots, JSON of the routes, and also other parameters. For example, in Pro, we are setting our travel mode to tracking time. So here the parameters of travel time that we pass to the service is tracking time. And you should be able to replicate what the parameter values that Pro sends to the service when calling Finite Routing service. So this is a workflow to take a complex problem you modeled in Pro to solve using routing service. And once you know the values to pass for each of the REST API parameter, you can then use the API of your choice to call the services. Now I will hand it off to Noah for a demo showing how to do finite routing, also known as the vehicle routing problem, with ArcGIS API for JavaScript.
Wow, thanks, Max. That was really awesome. What I'd like to do now is to solve the same problem that Max showed us, but this time using the ArcGIS API for JavaScript. So on the screen, you can see a very similar map to what you saw Max using in ArcGIS Pro, but this time we're going to be doing it on the web. And same as our first demo, you can see the link below to the actual application that I'll be showing off. So rather than tell you about it, let's go ahead and dive in. So here's the application hosted on GitHub. And we have the D in the middle that marks the depot, which is both the starting point and the ending point for our routing. We also have 3 different vehicles that are on 3 different routes, and each of them have 3 stops to make. Now you notice on the map there's some overlap in southern San Francisco, and here we've changed the widths of the routes to make it a bit easier to visualize, but of course other options such as transparency or using an offset could be available to you. Now let's take a peek at the console to see what helpful messages are there for us. So the first thing we see is these executing messages that are coming at about every second. And then we see some information about our routes and about our trucks. So it looks like the first truck travels a total distance of 44 miles and takes about 216 minutes to accomplish this. The second truck, a little bit longer, and the third truck, much less. So this information could be useful to us if we're tracking our overall route and if we want to monitor the health of our vehicles to make sure that no one truck has too many miles put on it. Now let's look at the code. So this time we'll be looking at the code using Sublime instead of in the console. So again, we're going to use Next as the version of the ArcGIS API for JavaScript. And while we don't want to use this in production applications, for development it's perfectly all right. So the first thing we do is we set up our API key. And this API key will be useful for authenticating for our base map, as well as to authenticate against the logistics service that we'll use for the actual fleet routing. Then we set up our base map and create a reasonable view. Then add the scale bar widget for scale. And then we'll create the depot. So this is that D that you saw in the middle of the screen, and we'll use this point later on. Next comes this promise.all statement. So what this does is it's going to ask us to resolve all of these functions before moving on in the code, basically making our asynchronous code act as if it were synchronous. So the first thing we do is we wait for the view to be ready, and then we call the getFleets function. And then after those are done, then we're going to pass in the results from the getFleets function, and the results will be the directions, the routes, and the stops. And we pass them on to their appropriate functions, being zoom to results, print route summary, show directions, and show stops. The show depot function we won't need to pass a variable into. Now let's look at the getFleets function. So I recall from reading the documentation that I can either use a feature server or a feature collection to pass in the information. Here we're going to use a feature collection. Now, because we're actually using the geoprocessor class, which I can show you up here, we're going to have to do a lot of the work manually. Now, the geoprocessor class is extremely powerful, but you really need to know all the properties and parameters of the service that you're trying to use. Fortunately, because I watched Max earlier, I have all the information I need. So let's go back down to our function of interest. So first, we're going to make that feature set, and this is going to be all the orders. And by orders, we're actually mean all the stores or all the stops. Now, each order is going to have a graphic with a geometry and some attributes. And these are the same attributes that we saw earlier when Max was using Pro. So we're going to make 9 of these stores for 9 orders. And then we're going to create our depot, which is the depot point that we saw above. And we give it a useful name, and we give it a time window start and a time window end. After we have our points, it's time to create the routes. Now, we want to make the routes and give it all the attributes, but we don't yet have the geometries because we haven't called the actual vehicle fleet routing service. So we'll get things set up and give them the useful attributes that we know they need. So for our routes, we have 3 different trucks, and we give them all the same start and stop, and they actually all have the same properties because it's a fleet of similar trucks. After we've created those, we're going to manually define our travel modes. Now, when we used the directions widget in the earlier demo, this was all set up for us and came from the service. But now, because we're not using the routing service, we need to set this up ourselves. So we add in all the attributes that we want for our possible travel modes. And we even have to include the description and the distance attribute and all the different information that Max showed us using Pro. Now, in the future, with the ArcGIS API for JavaScript, this process will be much more simplified, as I was saying earlier, and there'll simply be something like an ID key that you need to pass in. Now, after we have that, we're going to set up our official parameters. These parameters will take in things like the depot, all the orders/stores, the routes, our date, language, all the different defaults that we want to use, including our travel mode. And this is, if you're unfamiliar with the syntax, if the property name is the same as the variable name that contains the information, you don't actually need to use the colon and then type the name again. You can just write it once, and it's smart enough to know that travel mode : travel mode is the same as just travel mode. After this, we're going to get to our URL to do our fleet routing. Now, this is the URL for the job request, and Max showed you earlier the difference between the job request and the direct request. And offhand, I know that the direct request is good up to 2 different vehicles for fleet routing, but since we have 3, we're going to go ahead and use the job request to do that submit job. After that, we're going to set up our geoprocessor, and this is actually really simple. All we need to do is provide the URL and the out spatial reference. Now, this part is optional, but I found it kind of useful. So you remember when I showed you the browser console? This is the information that got submitted into the console. The first is we're going to have this callback option where we can actually display the status of the request every second and print that out to the console. So it wasn't terribly necessary for this demo, but it could be useful for the developer or for the end user to actually track what's going on. So in case an error occurs or goofy results occur, you can actually get that status back in the console. Now things are going to get a bit more exciting. We're going to create this job ID object, and the job ID will actually call the geoprocessor and submit the job with those parameters we saw above. Also, because we want to wait until the actual results are returned, we're going to pause the code until we get the results back. So that's what this await geoprocessor wait for job completion, and then we pass in the job ID, which is actually the geoprocessor submit job, as well as the options, which are going to submit the status of that request to the browser console. Once the geoprocessor job is done, it's time to get our results. We create this statement with an array of variables: directions result, routes result, and stops result. And we'll use an await promise.all to make sure that we return all our results before moving forward in the code. So we use a geoprocessor.getResultData method, and we'll use our job ID as the first parameter, and then the property of interest as the second parameter. And this property of interest we know from the documentation, and these are all string values. Next, we'll return the actual results. Directions will be in the directions result.value.features, and same for the routes and for the stops. After we have our actual data, it's time to look at it. So we create this helpful zoom to results where we just pass in the graphics from our routes, and then we zoom to those geometries. And one thing to note is we are doing some fancy work with our geometries, and this is just filtering out the null geometries. An example of a null geometry is a stop sign or a U-turn, where we don't need to display that in the app for this demo, but you might actually want for your application. After this, we're going to do another fun optional thing, and that's to print our route summary. So if you remember in the browser console, we saw the summary statistics for each different route. We saw the miles and the total duration, and I thought that was kind of handy to have in our application. And so this is that statement where we actually print it out, and then we format it nicely so that we can see it easily in the browser console. You could also do something else with this information, but for now, as a proof of concept, it seems pretty nice. Moving on, we have a nice helper function, which is called getTruckColor. We'll see this later on where we have the switch statement where depending on the name of the truck, we return a different color. And this will actually not only apply just to the truck, but to the actual route and to the stop symbology. Similarly, we have this get route width, as I was saying at the top, that we have different widths for different routes, and that just makes it a bit easier to see on the map. Then we want to show the actual directions on the map. So we'll take all the information that we got before from our geoprocessing task, as well as using the actual date and time. And we'll assign the color to the trucks, and we'll get the correct width for the routes. Notice that no symbology is returned from the server, as well as no pop-ups are returned from the server when we get the information back from the geoprocessing task. So we actually have to create our own. So we create a simple line for the route, and we make a handy pop-up. Lastly, we add those graphics in a new graphics layer to the map. If you're doing a larger enterprise application, you probably already have a graphics layer ready, but because this is just a one-off, it was easy enough to create a new graphics layer just to add it to the map. After that, we have our function to show those different stops, and these are all points, and we give them a logical color scheme, also based on the color of the trucks and of the routes, and we give it a good size and also a pop-up template. Then, because we also want to have labels for our stops, we have a helpful label object here, and we'll give them some text, and we'll set the size and the weight to be appropriate. And again, the color will be similar to the trucks and similar to the routes. Then we concatenate our labels and add it to a graphics, and add that graphics again to a new graphics layer. Then we show the depot. This is the big D we saw at the beginning. It's a simple marker. Add some styling to it, and then we add that to the map again in a new graphics layer, and we're done. And now that we've seen all the code, let's go back and look at the app again real quick. So here we are, and before we didn't test out the pop-up, so let's go ahead and see what that looks like. Now I'm going to pick a segment that has two different routes on it, meaning that two different vehicles will travel along the same path. And if I click on it, I get that pop-up that we set up earlier. And I see that the first pop-up is for the top route, which is truck number 2 in blue. I see what the turn-by-turn directions are, as well as the arrival time for the segment. Then if I click to the next pop-up, I can see that below it is also the information for truck number 1, which is on the red route, and its turn-by-turn directions, as well as the arrival time. Then if I'm curious about what's occurring at each stop, I can click on that and get the pop-up and see, yes, this is store number 3. Truck number 2 comes here, it makes one stop and delivers one item. And now I'll hand it over back to Max to take us home. Max?
Thank you, Noah. So to wrap up, here are the things we talked about in the presentation today. We talked about the 6 routing services Esri provides and highlighted some of the capabilities of each of the services. I showed you how to use the developer side to learn about the routing services, and how to find the examples for using various APIs to working with the routing services. I also showed you a workflow to model a complex fleet routing problem in ArcGIS Pro and inspect the parameters ArcGIS Pro sends to fleet routing service. And you will be able to replicate what Pro sends for each of the parameters to the fleet routing service. We also saw how to use the directions widget and geoprocessor class with the ArcGIS API for JavaScript to solve simple and complex routing cases. Noah also showed you how to access the services using API keys. And here are some resources if you want to learn more about them. Thank you for attending our presentation. Please provide your feedback for this session by clicking on the session survey link directly below the video.